welcome to this workshop where we are going to chat about self, which is, in one line, a ZK identity protocol. So using it, you can scan your biometric ID or biometric passports and then generate zero knowledge proof to prove that you are above 18, that you are not part of a list of specific countries. And each time, because it's ZK, you don't have to reveal anything else. And these proofs, you can verify them on a backend server or directly on-chain if you want. So the plan about today is for me to give you a bit of more context on the project. What is the vision behind? Then we can chat about the Bounties because, of course, we are sponsoring the hackathon. And finally, if we have some time, I can directly deploy a contract on Celo testnets and generate a proof of passport and verify it. All right, so what is the idea behind self? So let's say that you want to verify the identity of your users online. Today, it's pretty hard. The current fallback solution is the well-known KYC, which is bad for many reasons. First, it's not private, which means that you are going to leak all your personal information with the third-party verifier. Then it's not super secure. Like using generative AI, now it became childish to pass this KYC process. And finally, the user experience is pretty bad. So each time the user will have to find its ID documents, scan it, send it information, and then wait for verification. So if you're an app that needs KYC, you are going to experience a lot of drop-off at this point. So that's why we decided to build Self. And now the protocol is live since ETH Denver. And to do so, we decided to leverage the most trusted attestation of who you are, aka the biometric passport. So these documents, they are a pretty good match for many reasons. First, they are quite difficult to obtain. Also, they are unique to individuals, unless you have a dual citizenship, of course. And also, people have this intuition that they should keep these stored securely, because you need that to travel, right? And finally, and most of all, they are machine readable. So you can scan a passport using OCR reading, but you can also scan it another way. Because do you know what's inside a biometric passport? There is a chip which contains all the information about the documents, but also the digital signature of the passport. So you can verify this signature in zero knowledge. And if you do so, and that's exactly what you are going to do using Self, you can already solve most of the identity problems of the field, like the Sybil resistance, how to prove that it's a real human who's behind an action, a vote, a tweet, a transaction, or anything else. Using Self, when people are going to generate a ZK proof, they are going to verify that the passport is genuine. So they are real humans. And when you verify the proof, as a developer, you can have access to a unique nullifier for each person. So this way, if you plan to organize an airdrop, for example, you can make sure that each person can claim it only once. And it's extremely simple to do using the smart contract SDK. All right, but you can do better than that. You can reveal anything else related to the passport information, like your name, your date of birth, your date of expiry, your nationality, your gender, anything that is inside the passport, you can reveal it. But of course, only if you aim to do so. And lastly, you can directly prove facts about you directly in zero knowledge. So you can prove that you are 18 plus or 21 plus. You can prove that you are not part of a set of specific countries, or you can directly prove that you are not part of the OFAC list. And each time you are not going to reveal anything else, because these are going to be proven inside the zero knowledge circuit. So for example, for the OFAC check, what we're going to do is take the OFAC lists, put it inside sparse Merkle trees, and then you just have to do a proof of non-inclusion of like your passport number inside these sparse Merkle tree, which is, I think, pretty cool. All right, but what does the experiment look like and how does it work exactly? So the first step is the registration. In this one, you are going to scan your identity document, so the biometric passport or the ID card, because the big news that we had for if CC is that we are now supporting biometric IDs, like the biometric EU ID. But not only like, I know that Vietnam and Saudi Arabia are also issuing biometric IDs. So yeah, pretty good. So yeah, you have to scan the ID documents using OCR reading because in a second time you will read the chip who's inside the document using the NFC reader of the phone. And this chip is protected by your passwords. And this password is present on the main page of the document. Everything during the onboarding is achieved locally on the phone, such that when you have the passport data, you are ready to verify your first zero knowledge proof. And in this one, you are not going to reveal anything about you beside the fact that you own a biometric document. And in the second step, so once you got registered, you can now disclose stuff and prove stuff about you. So in this flow, people are going to scan the QR codes or open a deep link. They can do this too. And then is going to get prompted on screen, oh, this application wants me to reveal that I'm 18 plus, that I'm not part of the OFAC list, or such things. And then you just have to confirm, generate a new zero knowledge proof, and send it. And then the proof got verified by the smart contracts or the backends directly. So this is the flow, the high-level architecture of the disclosure. So mobile app scan the QR codes, then it's going to connect to a TA. So a TA is a trusted execution environment. We are using this right now to generate the proof. A TA is a black box. It's going to generate an attestation in which there is a hash of the code running inside the TA. And the code running inside the TA is designed to do two things: generate the ZK proof, and then delete the passport data, and that's it. So we can't see the passport data, we don't store it. It's only stored inside the secure enclave of the mobile device, and that's it. And finally, the proof is going to be relayed directly on chain, or if it's HTTPS, it's going to relay to an endpoint. What's good is that you don't have to think about gas fees because we are going to relay the proof directly for you on chain. So people don't even have to send a transaction. All right, let's chat about bounties now because we have a bunch of them for this hackathon. So it's pretty much the same as for if type A in a way that we have two categories. The first one and the most juicy one is on-chain verification. By the way, we improved a lot the on-chain SDK, so it's now easier than ever to hack on self. So for that one, it's best overall, and the first prize is 5K. The second one is 2.5, and the third one is 1.5K. And if you decide to hack off-chain, you can still earn something. It's going to be less important, but there is still 1K for the best overall. So I think that now Kevin is going to give you words on the developer tools that we have for self.
Okay, hello. So for this hackathon, we actually released two very developer-friendly tools. So first one is for Vibe Coder. So right now we have our self MCP for every, like, if you want to do vibe coding, you can just install the MCP and tell that, okay, explain how to integrate, or just that MCP generate code for you. You don't have to read the document yourself, even so then you can generate all the code you need. So that's the first one. And the second one is our Tool.xyz. So this one is actually all you need to hack on self on-chain SDK. So what does this tool actually help you? So you can set and read your verification config on this website, and then you can calculate scope for your contract, and you can also get the testnet token. So I want to give a quick demo about this this website. So here you can see, if you have any question, please join our Telegram community. All of our developer and Remi, me were also in there. So make sure you are in this Telegram group. So if you meet any problem, you can just send via here. And so here you can connect your wallet. And if you want to set the verification config, you can connect your wallet here, or we just use the example here. I can connect the wallet, I guess. Okay, you wanna?
I think it's better to do this on. All right, I think we can just skip this step and you can just explain what's happening.
Okay, so if you want to generate scope, here you can just type your contract address where you deploy and then integrate with our self verification root contract, and then use the scope exactly the same from your QR code wrapper. Let's say my or say app. Okay, then here is the generated scope. You just have to copy and then pass to your contract, so you don't have to worry about the scope part. And then for the read part, you can generate the verification config on top of using here. You can set, okay, I want all the user at least above 18 years old. You can select the exclude country you want, and then you can click, okay, I want a OFAC checklist 1 and 2. You can set the verification config here. And also, once you set the verification config, it will generate ID here. And here we are using example ID, so you can directly read config here. So this is the default one. So this means that, okay, I don't set any age gated here. I don't set any forbidden country and OFAC. So this is the default one. If you just want to verify that your user is real human, you can just pass this config ID into your smart contract, then that's it.
Awesome. Thanks, Kevin. I guess that now we can directly move to the code implementation and get our hands dirty because that's what's exciting during hackathons. So for that, we created a GitHub repo. You can go on self-XYZ organization on GitHub and clone the workshop repo. This one is separated in two parts. You have the application and the contract subrepo. Inside the app one, you will find the Next.js application, which is going to run a front end to generate the QR codes. And then people are going to generate the proof from these QR codes. But you can also find a backend to verify directly the proof there. But in our case, today, we are going to use the contract repo to deploy smart contracts on Celo testnets and directly verify the ZK proof there. But it's totally up to you if you want to verify the proof on the backend or if you want to verify it on the smart contract. You just have to specify it in the front-end SDK. But we are going to see this together. So, all right, let's do it. I have my repo here. So personally, I'm using Ben. So the first step for me would be to init the subrepo, running run install. Oh, I can try to do so, yeah. Is it better this way? More? Oh, wow. All right. Oh, it's because there is a little window in the window. All right, I see. Got it. All right, so you can do that. Then you need to do the same inside the contract repo, of course. So you can do ben install, the same. And then in the app repo, you can just directly run the Next.js application. So you can do ben run dev. And it's going to run the app directly on localhost. So you can see that here, I already have displayed my QR codes that I can use with the Cell app to generate a proof. So, oh yeah, there is one thing that you need to do is check the .env files, of course. If we check the one in the app repo, what you need to put there is the public endpoint. So it's going to be a contract address if you want to verify the proof on chain. And if you want to verify it on a backend server, it's going to be your DNS. Put a public one. So if you don't have a DNS, you can just use ngrok, and it's going to be extremely easy to use. Then for the name and the scope, you can just let it like that. And the .env in the contract repo, let's check it here, but you have a private key, the Celo API key, and the two other ones, you can just let it there like that. All right, so if you want to try with mock passports, I'm going to show you, but you can generate also a mock passport inside your application. You want to verify the proof inside Celo testnets. So you will need some faucets, and you can grab these from the tools page that Kevin just showcased right before. All right, so now that we put everything, I can just directly deploy the smart contract. So to do so, I can do run deploy. And let's hope that we have the Wi-Fi here. because usually it's pretty bad during these conferences. All right, it's working well, perfect. So now there is the contract. Maybe we can take a look at the contract together. So that's the one. You can see that it's inheriting the self-verification roots smart contracts. And I think there are like just two main things that you need to remember, which is these contracts, you just need to implement a custom hook verification inside of which you can put directly your codes, but everything else, like the proof verification itself, is going to be abstracted. You just have to put like directly the hook. So now that the contract is deployed, I can go to the tools.xyz and set up the scope. The scope is extremely important. The idea behind the scope is to make sure that when users are going to generate a ZK proof, they are going to generate it only for your smart contracts or your backend, but for nothing else. So I can just take the contract address here, and if I go there, and then I go to tools.self.xyz, I just have to put the contract address there and here in the scope seeds. I think that mine is self workshop, if I'm right. Yeah. And then there is another script ready for you, which is the set scope.js, and you can just copy paste the scope here. All right. And now in the contract repo, you can just do bun run set scope. And it's going to update the scope on the latest deployed smart contract. So in the meantime, what you can do is go on the App Store and look for the application self ZK, or if you want, you can alternatively just scan the QR code and it should ask you to download the app. So this is the first screen of the mobile app. If you don't have a biometric passport, or if you want to hack on the testnet, you can just click 5 times here, and by doing so, you can generate a mock passport. So it's going to follow the same specification than the real passport. The only difference is that you can't cross the border with it, obviously. But you can still cherry pick your country, the birth dates. If you need like more options, you can just directly reach out to us. So I generate the mock passports, and then it's the same flow as the usual registration for the real passport. So I'm going to generate a zero knowledge proof, which is going to verify the digital signature of the documents in real time. So it should take something like 10 seconds upon the country, and once the proof got verified, you are ready to hack with your mock passport. Of course, only on Celo testnet. So once that it's done, I think that I need to refresh this page. All right, I'm going to, oh wait, there is one more thing that I need to do. I need, of course, to update the endpoints of my smart contract address. So I think that this is the smart contract address. And I can just go in the .env of the app repo, and then I can just put the new smart contract address here. So when it's done, I can just refresh this page. Now I scan the QR codes. On screen is going to be prompted, hey, this application wants you to reveal that your nationality and your gender. And you can even put additional information. So here I put, bonjour, Can. And you can see the endpoints on the screen too. So there is the smart contract address in my case, which is OX3C, which is the same. So I just have to verify the proof. The proof is generating. It's going to take a bit more time for this one because it's going to get verified directly on chain. And once the proof got verified, we can check on the testnet explorer, identity verified. And I think it's Alpha Jores. Yeah. Let's take a look at the contract. And you can see there that we just called the verify self-proof function. So let's just directly read the contract. And you can, if you check in the last output, you are going to see the passport attributes that I revealed. So there is USA, and for the gender, that's a boy. You can also check the last user address used. So that's the one. And if you double check in page.tsx here, the address is just set up here. So you can just use the self-workshop repo as a boilerplate and just use it as you want. All right, I think that's pretty much it for today. Maybe one more thing that is interesting to know is that this project is actually fully open source, so you can scan the QR code and go on the GitHub repo. Don't hesitate to start it. Or you can scan the QR code on the right and just check out the self website. All right, thanks everyone for today. And I don't know, but maybe we have some time for a Q&A session. All right, we have some time? Yeah. All right, any questions? Yes, we have one here. Wait, 1 second, I think we have a mic for you.
Hello. Hi, so it's a bit unrelated to the hackathon, but why choose TEs instead of ZK proofs?
Instead of?
ZK proofs.
ZK proofs, so the project is using ZK proofs. ZK is a type of cryptography that allows you to generate a proof about the statements without revealing why a statement is true. So in our case, the statement is my passport is valid because the digital signature of the document is valid, and the why is the passport data, and you don't want to reveal the why. The idea is to replace KYCs with something that is privacy preserving. So this is why ZK and identity is such a good match.
No, I meant TEs. Why do you use TEs?
All right, why are we using TEs to generate the ZK proof? Oh, that's a really good question. So because countries are using different signature algorithm and a hash function, and some of them are using like big curve algorithm like SHA-512 with SECP 521, the Z key can be up to like 2 to 5 GBs, and you can't ask people to download this. So we used to do client-side proving before, and we are going to get back to client-side proving, but unfortunately, the current state of ZK is what it is, and before new stacks like Noir and Honk get audited, we have to stay with Grow16 and SciComm, which leads to like huge proving keys. Okay, but everything, by the way, had been audited by ZK Security 2 times.
Thank you. Any more questions?
I was wondering which use cases are you most looking for with this?
That's a good question. I would say that you have 2 main use cases. The first one would be Sybil resistance, so airdrop, captchas, anything like maybe giving products that are free for people, but they can claim it only once. And then you have whatever would be like maybe gatekeeping contents on passport attributes, like 18 plus stuff, the fact that I come from a really specific country, so it's going to unleash voting, for example. But also, I think that we're extremely interested by people to get extremely creative with the passport attribute. So you could create like a social network where I could create a post and gatekeep the comment on this post, like a Reddit subreddit that would be gatekept on any of the passport attributes. So I would say that for this hackathon, just be creative. That's pretty much it.